In this video, I'm going to provide a brief summary of the probability unit in kind of one big, beautiful package tied up with a bow, hopefully, for you. So the first thing we're going to talk about is simple probability, and then we're going to talk about how to count outcomes, and then we're going to review how to find compound inequalities. So remember, simple probability is just the favorable outcomes over the total number of outcomes. If there's just one event, this is your go-to. For example, if the spinner to the right is spun once, okay, so we have one event there, what is the probability that it lands on a star or a shaded region? So all you have to do is count up how many stars there are. It looks like there's 4, and then 5, 6, 7, 8, 9, 10, 11, 12 shaded regions. 12 shaded regions out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 total. And then you could reduce that to 3/4. Okay, so even though it talks about two different things, it's still just one event of spinning a spinner. A box contains 6 red popsicles, 2 blue popsicles, 8 orange popsicles. If a popsicle, 1, is drawn at random, what is the probability that it is not blue? Okay, so it's just one event. So there's 6 and 8 is 14 out of 16 popsicles in the box. That's a 7 out of 8 probability that it's going to be not blue. Okay, so just remember, simple probability, if it's just one event, is the number of favorable outcomes out of the total outcomes. Now, in this unit, we also discussed how to count different kinds of outcomes because all of the probabilities are based on this. The favorable outcomes, the ones you're trying to get, how many of those there are in that experience, if you will, out of the total outcomes. So to figure out the total outcomes, sometimes we have to apply the fundamental counting principle, which I like to call the FCP. So if you're trying to find the number of times something happens or the number of possibilities that there are, you're going to multiply the number of possibilities from each group. So if you're finding the number of possibilities and you're picking one item from each group, then the fundamental counting principle is your go-to. For example, how many different pasta bowls can be made using one item from each category? So I'm not picking multiple items from each category. I'm not picking multiple items from one category. It's one item from each category. So all you have to do is multiply. Let's see, there's 1, 2, 3, 4, 5 different kinds of pasta, 2 different kinds of sauce, 4 kinds of meat. You just have to multiply those all together. And I believe that's 40 different pasta bowls that you can make, choosing one item from each category. Permutations and combinations are for when you're picking several items from one group. That's when you go to permutations and combinations. Permutations are when you're picking several items from one group and the order matters. For example, if you're choosing officers from a club or the order of letters in a code, etc. Combinations are for when you're picking several items from one group and the order doesn't matter. If you're just choosing two students from a group of 8, or you're choosing 2 sides from maybe 8 sides for a meal, etc., then you're talking about combinations. And again, all of these counting outcomes, the fundamental counting principle, the permutations and combinations, they're important for figuring out the total number of outcomes that you could have from different events when we're talking about probability. If you're finding the probability that an outcome occurs from 2 or more events, so something's happening over and over again, then you're dealing with compound events, and you just multiply the probability of each event, remembering to decrease the total amount if it's dependent. So for example, a coin is tossed and then a letter in the word accomplishment is chosen at random. Find the probability of heads and then a vowel. So the probability for a coin for heads or tails is 1/2. And then the vowels are 1, 2, 3, 4 out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 letters. So the number of combinations that I could have of heads and tails and then letters there is 28 different outcomes. That's my number tree or tree diagram. I could have heads and tails, and then off of heads and tails, I could have all of accomplishment, and then accomplishment off of the tails too. And I would come up with 28 different possibilities. That's where the fundamental counting principle comes in. I have 2 choices for the coin. I have 14 choices for the word accomplishment. 2 times 14 is 28. That's 28 different outcomes of ways that that could happen. And then there's 1 way that I can get a head, and there's 4 ways that I could get vowels. So that's a total of 4 different outcomes that have heads and vowels. So the probability is 4 out of 28, which reduces to 1/7. Second example, a bag contains 5 Snickers, 9 Milky Ways, 2 Crunch, 12 Twix. If Jack randomly selects a candy bar, eats it, and then randomly selects another, find the probability that both candy bars were Milky Way. Okay, so there's 9 Milky Way out of 14, 15, 16, 28. Do I have that right? 9, 10, 11, 16 plus 12 is 28. Yes. Okay, but he ate 1. So now there's only, so it's not multiply, or not equals, it's multiply. He ate 1, so now there's only 8 Milky Ways left and 27. We always assume that he was successful when we're counting our outcomes. Okay, so he actually got that Milky Way that first time. So there's only 8 left, and then there's only 27 total bars. And then you would just multiply those together. 9 times 8 is 72. And 28 times 27 is 756. And that'll reduce, but I'll leave that up to you to do. Okay, so I tried to kind of put all of these topics together for you in one thing. So if you're finding probabilities, it's asking you to find a probability, you're going to ask yourself, is it one event? I'm selecting 1 candy bar, I'm spinning the spinner 1 time, or is it 2 events? I'm selecting 2 things, I'm selecting a candy bar and then and then selecting another one. 1 event or 2 events. If it's 1 event, it's favorable over the total. If it's 2 events, it's still the favorable over the total times the favorable over the total. And again, if it's a dependent event, your total is going to change and your favorable is going to change potentially based on what happened in the first event. But the idea is still the same. You're going to multiply the 2 things together. If it's asking you to count outcomes, you need to ask yourself, am I pulling 1 item from each category, or am I pulling multiple from 1 group? If you're just doing 1 from each category, each group, then you just multiply the number for each category together, and that's going to tell you the number of outcomes. That's the fundamental counting probability. That was our pasta, and then our sauce, and then our meat. Just multiply the number of each category together. That's the fundamental counting principle. If you're pulling multiple items from 1 group, you have to ask yourself, does the order of those items matter? If it does, you're doing permutations, and it's this formula right here. If the order does not matter, for example, if I'm just selecting 2 kids from a group of 10, how many different ways can that happen? That's combinations. It doesn't matter who's first and who's second, unless you're talking about my own children. It doesn't matter. As long as we're just selecting 2 from each group, how many different possibilities of selection of 2 can we come up with? That's going to be combinations, and you're going to use this formula. And it's N is the number of things that you're pulling from each group. No. N is the total number, sorry, I said that backwards. N is the total number of things in the group, and then R is how many you're pulling from that group. N things taken R at a time. Hopefully that helps you kind of tie all these concepts together of probability. And I'll see you next time.